This is still section 3.2. Let's take a look at this diagram of a hexagon. And this little project here is figuring out the angles in a hexagon. It says draw a regular hexagon with sides 8 centimeters each. So something to point out, when we talk about a regular hexagon, that means that all of these sides, this guy here, all these interior stuff, they're all equal in length, all equal in length. And if I look at these outside guys, each one of those is equal in length to each other. Each one of these distances the same. And likewise, all the angles that I see are equal in measure. Equal in measure. So our job is to get some angles in here using what we just learned. And one of the things that I want to point out to you is that when you have a regular hexagon, it could be a pentagon, it could be an octagon. I'm just going to draw some lines in here. I got that guy in there. And I'll draw this guy here. I'm just trying to find the center as accurately as possible. I'll put this guy here. Okay, so you can see that they all cross right here in the center, right here in the center, and they form what's called equilateral triangles or equiangular triangles. And that means that this triangle right here, this guy here, is the same as him, is the same as him, is the same as him, same as that, and so on. And further, this angle right here, from the center to here and to over here, those are all the same. Well, what did we learn about a triangle? All three angles have to equal 180 degrees. So if I call the first one x, then this is x, and this is x, and if I add them all together, that's 3x is equal to 180 degrees, and that means that each one of them is 60 degrees. Each one is 60 degrees. So one of my little questions here, and it doesn't matter which guy we do first, we're going to answer the questions A through F. I'm just going to take this out so you can see it. I am looking for this angle right here. That's what F is. Well, if I know that this part over here is 60 degrees and this guy over here is the same, then I've got 60 plus 60, which means that F is equal to 120 degrees. 120 degrees. Okay. Well, let's see. What else can I figure out? How about we go to E? This is one of those parallel lines that we had seen before. Okay, so this angle is going to be the same as this angle. So E is 60 degrees. And if E is 60 degrees, this guy is 60 degrees, what's D? Well, it's 180 minus 60 degrees, so that's 120. 120. And this is a regular hexagon, so what's C? Well, C is going to be the same as D. So C is 120. And B is going to be the same as E. So it's going to be this 60 degrees. And finally, let's look at this guy out here. That's really this fellow here. This fellow right there. Same thing. And if I know he's 60 and I know he's 60, and the whole thing is 360, so I have 360 minus 60 and 60, so it's 360 minus 120, so what is that? 240. 240 degrees. So this guy A, 240 degrees. And I can keep going on and on and on about this hexagon and even different shapes, just as long as I know it's regular, meaning that everything is the same in terms of measurement and length. Okay, we have one more that we're going to be doing in class. This is pertaining to a window. Okay, windows come in lots of different shapes, and this one has 1, 2, 3, 4 sides to it. So this is like I guess it's the molding around it. Calculate the angles in the trapezoid window. Trapezoid window. Why is it called trapezoid window? Well, because it's got 4 sides, and these 2 sides are parallel to each other, and these 2 guys are not. Okay. You can assume that the bottom two corners are right angles. So we're going to make that assumption right here. Right here. Okay. You may assume that the outside trapezoid is proportional to the inside trapezoid and the thickness of the frame is consistent, meaning that the thickness here is the same as the thickness here, is the same as this, is the same as this. And this shape on the inside is exactly the same as the shape on the outside, except it's drawn in. Well, let's take a look at this. Let's see. Calculate the angles. So let's find some angles. So I know that this is 70 degrees right here. This is 70 degrees, which means that this is 70 degrees, which means that each one of these guys is 35 degrees. Okay, I know that. I know that if this is 70 degrees and all the way around is 360, so it's 360 minus 70, so what is that, 290? So that from here to here is 290. And half of that is what, 145? 145. Okay. And if this is 70 and this is 90 and this is 90, well, what's this? Well, that's a good question. One of the things that we learned was that in a triangle, any triangle, all three angles add up to 180. Well, let's think about that. Let's say I had a four-sided figure. Well, if this triangle is 180 and this triangle is 180, then what's the total? Well, that's 2 times 180, which is 360. So there's a little rule that you can use that if you have a four-sided figure, four-sided, that the total of all of the interior angles, these guys here, is equal to 360 degrees. 360. So I've got 90 plus 90 plus 70 is equal to 360. So 360 minus 90 minus 90 minus 70. So it's 360 minus 180 minus 70. 360 minus 250. What is that? 110. So this angle here is 110 degrees. And if I know that angle, then I can break this apart. Each one of those is going to be 55 degrees. And on and on and on. And we'll do some more of this in class and talk about different shapes as well as a four-sided figure and see if we can come up with some kind of pattern.